Alright, today we're going to take a look at some features of a graph. So here we have two cubic functions, but I just want you to get used to being able to look at a graph and think about, okay, what is the end behavior, what is the domain and range, how many maximums and minimums, like turning points, do I have, how many times is this crossing the x-axis, what is my y-intercept, and we can get a lot from the graph, but we can also get a lot from the equation. And so what I want to show first is domain and range. With these functions, domain is all real numbers in this case, and range is also all real numbers. We have unlimited number of x values that we could plug in and get an output. And so domain and range are all real numbers. If you want to do integral notation, you could say it's from negative infinity to positive infinity. Now, what about end behavior? So as x is getting larger and larger, as x is approaching infinity, y is going up. So when I look at the end of this graph, we're going up, so that is positive infinity. As x approaches negative infinity, notice that my graph is going down. So as I move left forever and ever, I am approaching negative infinity. Now, max and minimums. We're going to find these using our calculator, but I just want you to notice that we have two changes of directions here. And they occur at what's called the extrema here. And these are relative. This is a relative maximum, and this is a relative minimum. And so we have a total of two. Now if I have two changes of direction, and I add one to that, that means my highest exponent, or my degree, is going to be a 3. So if I have 5 changes of direction, then I'm going to have a degree 6, like an x to the 6th power. If I have no change of direction, meaning it's just a straight line, then that's linear, right? Y equals x. It would be a straight line. Now, the number of x-intercepts will also tell us the degree of our problem too. And so if I cross the x-axis at 3 different places, there's a good chance, depending on the situation, that it's going to be x to the 3rd power. So the fact that our x-intercepts line up with how many times we change directions is a good sign. Now the y-intercept, not only can you see that graphically here at -7, but you also can see it as the constant inside our equation. Now we're not going to go through all of those again for the next example, but on this next example, let's just take a look at domain and range again. So even though it's flipped, looks similar but different, these are all real numbers, so all x values, all y values, all real numbers. There's nothing I cannot have. Now, notice the difference though, as x is getting larger and larger, when I look at the end behavior, or at the arrow, my arrow is pointing down, so this is negative infinity. And then as I move to the left forever, I notice that my arrow is pointing up, so this is going toward positive infinity. So now these are opposite of each other. And what makes them opposite is that one has a negative out in front, and one does not. It is a positive. And so we have to pay attention to our letter A, our A value, to not only show a shrink or a stretch, but also to show if we flip or reflect over that x-axis. So I just want you to be able to take a look at a graph and an equation and be able to pull some of these key features from the function or from the graph.